in this problem, I'm given the point 2, -3, and I'm told this is on the terminal side of angle theta. And then I'm also told that theta is in standard position. Which is very important to know. So an angle in standard position, here's my y-axis, here's my x-axis, means that the vertex of the angle is at the origin, and the initial side is the x-axis going positive. Now I know that a point on the other side, on the terminal side of this angle, is the point 2, -3. Well, that point, let's say, is right here. So this angle is shooting out that way. It's in quadrant 4. I can tell that because they gave me the sign, positive and negative sign, of the point. I'm going to actually make this a little bit, I'm going to make this a little bit bigger here so we can see it just a little bit better. Okay, I'm going to go 1, 2, 1, 2, 3. Make my point right here. And then I have a little bit bigger angle to work with. Now, nowhere in this problem does it say it's a unit circle. And we know it's not a unit circle because a unit circle, by definition, unit circle has a radius of 1. And I know when I have a unit circle, the radius is always the hypotenuse of any right triangle that I'm making. Here I would make the right triangle this from this point right here, lifting a perpendicular to the x-axis. And I know that that distance isn't 1 because I know that this distance is 2, and I know that this distance is 3. It happens to be a -3. So there's no way that my hypotenuse could be 1. Because the hypotenuse is always the longest side of a right triangle. And certainly if I have a side that's 2 and a side that's 3, there's no way that I can have a hypotenuse of 1. So I know, it doesn't say that it's a unit circle, so I know it's not a unit circle. So what I'm going to do is I'm going to find out what is the length of the hypotenuse. And I'm going to use the Pythagorean theorem to do that. My right triangle there is 2 squared plus 3 squared is equal to my hypotenuse squared. So I have 4 plus 9 is equal to h squared. So I have h squared is equal to 13. So h is equal to radical 13, square root of 13. So the length of my hypotenuse is the square root of 13. Now you remember the 6 trigonometric functions, they are all simply ratios of the sides of a right triangle. And in order to remember that, how to calculate them, I use the acronym SO, CA, TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So now I should be able to find my 6 trigonometric functions. I write them down properly: sine, cosine, tangent, cosecant, secant, cotangent. And I'm going to start with sine. So sine, first of all, let's make clear again. This angle right here, this is my reference angle. It is the acute angle from the terminal side to the x-axis. There are two angles from the terminal side to the x-axis. There is the acute angle, which is my reference angle. There's also an obtuse angle from the terminal side to my x-axis, but I don't care about that. I want my reference angle, which is the acute angle from the terminal side to the x-axis. So sine is going to be opposite over hypotenuse. So that is going to be, let's get a little calculation area over here. It's going to be 3 over radical 13. So let's get my calculation area. Sine is equal to 3 over radical 13. I'll multiply by radical 13 over radical 13. That's going to equal to 3 radical 13 over 13. So I know that the value is going to be 3 radical 13 over 13. But while I'm at it, excuse me, I may as well remember all students take calculus. All my trig functions are going to be positive in quadrant 1. Only my sine is going to be positive in quadrant 2. Only my tangent is going to be positive in quadrant 3. Only my cosine is going to be positive in quadrant 4. So since I know I am in quadrant 4, I know that the only thing that's going to be positive is my cosine. So my sine is going to be negative, as will its reciprocal cosine, cosecant. Cosine is going to be positive, as will secant. And tangent is going to be negative, as will cotangent. So now I've got the positive and negative signs all set up. So I have my sine now. My cosine is going to be adjacent over hypotenuse. So 2 over radical 13. And let's do a little calculation there. So cosine is going to be equal to 2 over radical 13. Let's rationalize the denominator. So I have 2 radical 13 over 13. That's going to be my cosine. 2 radical 13 over 13. Now, what about my tangent? I like to give my tangent as sine over cosine. But tangent is also opposite over adjacent. And if I look back at my triangle here, my opposite over adjacent, my opposite is 3, my adjacent is 2. My opposite over adjacent is 3 halves. So I know that my tangent is going to be negative 3 halves. And if I did it as sine over cosine, I would have had 3 radical 13 over 13 divided by 2 radical 13 over 13. I can multiply by my reciprocal on the bottom, 13 over 2 radical 13, and on the top, 13 over 2 radical 13. This cancels out to give me 1. My 13s cancel out. My radical 13s cancel out. And what do you know? I am again left with 3 halves. And since I know with the sign, SIGN of it's going to be, that's going to be negative, I know that I have negative 3 halves. Well, some of these now I can get pretty easily. I can certainly get cotangent pretty easily, because cotangent is the reciprocal of tangent. So my cotangent is going to be negative 2/3. My secant is going to be the reciprocal of my cosine. And I look at how I was calculating cosine. And if you remember, I started out calculating cosine, it was right here. It was 2 over radical 13. Well, the reciprocal of that is pretty easy. It's just radical 13 over 2. So my secant is going to be positive radical 13 over 2. And my cosecant is going to be the reciprocal of my sine, which before I rationalized it was 3 over radical 13. So this is going to be negative radical 13 over 3. And those are my 6 trigonometric functions to solve this problem.